So we were discussing about losses, right? Losses with respect to the runoff, and we have seen various sort of losses. How we can find out those things like evaporation, transpiration, evapotranspiration, right? Those things has been already discussed, and we are into the new thing that is called infiltration, and we have discussed the definition of infiltration as well, and what are the amount of water we should consider to be infiltration. That is also been discussed, right? So the definition was given. The definition was given, right? And we have seen this zone, how this infiltration is affecting the soil moisture content and other thing. We have seen what are the various sorts of zones. We have seen the models by which we can understand how infiltration works, right? And we have discussed about two different definitions, that is called infiltration rate and infiltration capacity. So what was the difference between infiltration rate and infiltration capacity, or should I say what was the relationship between the infiltration rate, infiltration capacity, and the intensity of rainfall? What are the relationship? Suppose we are denoting infiltration rate as F, infiltration capacity as Fc, then what are the relationship? No. In terms of infiltration rate, infiltration capacity, and the I, that is the intensity of water, what was the relationship? Achha, let me give you some example that when I can say F will be equals to Fc, when I can say that infiltration rate will be infiltration capacity, that means maximum rate by which infiltration can occur in a particular station or particular field, when it will occur, I equals to 1. কি ছিল গো? There will be relation between I and Fc, that is I will be greater than, this will occur when I will be greater than or equal to maybe maximum Fc, right? So if the intensity of water, that means volume of water or the depth of water, as because we are considering per unit area, so we can consider a depth as well. So depth of water coming into the field per unit time is equal to or greater than, it can show what infiltration can occur, the depth of water divided by or per unit time, right? So if that happens, we can say F can be equals to Fc. Other than that, we can say F will be equals to I. That means if the rainfall intensity is lesser, rainfall intensity is lesser, by which it can the water can be infiltrated into the soil, then we can say the amount of rainfall is totally infiltrated inside the soil surface. That means in that case F will be equals to I, right? And we have seen what are the factors affecting the infiltration, and we have seen this one as well, that is how we can measure the infiltration, what are the processes, that is one is single ring and double ring, and we have seen this relationship where Fp with respect to time in a field, particular field, how it varies. So initially the infiltration capacity will be higher, then gradually it will be decreasing, and at a particular time, after a particular time, that will be there will be a steady infiltration. And we have seen this equation as well, by which we can find out the infiltration in a particular field, infiltration capacity in a particular field. We can find out if the other data are known, right? Now we have to find out by equation. We have seen how we can find out the infiltration capacity, but let us see how we can find out the infiltration by different method, that is by finding out some index or indices, right? So this will be called the infiltration indices, and the definition will like be this one, that the average infiltration rate is called infiltration index, right? Average infiltration rate, as because we have seen that infiltration capacity will vary with respect to time, but if we take the average out of it, right, if we try to find what is the average infiltration rate in a particular field, that we can call as indices, infiltration indices. What are the indices are there? Phi index and W index. So phi index is very much important, right? There may be some numericals with respect to this phi index. Yes. So try to understand how we can find out the phi index. If the data of rainfall and the data of runoff are given, those are given, then how we can find out the phi index, that is the infiltration in a particular field, and W index, that will be given by one formula. I will come back to that as well, right? But most important is the phi index. Now what they are saying, that average infiltration rate, if we find out, how we can find out that one? Let us see. Suppose we are having this, what will be this called? This graph. What will be this graph called? Here in this direction rainfall intensity is given, in this direction time is given. Heatograph or hydrograph, whatever you pronounce it, right? Okay. Suppose we are having this heatograph of a particular storm, right? So we are having a storm from 0 to 14 hours, and with respect to 2-hour interval, we are having various intensities of rainfall, and those are plotted in heatograph, right? Our aim is to find out this value of phi. That means the losses, right? The losses due to the infiltration. The main loss happened due to the infiltration, right? Whenever we are considering runoff, obviously remember this, whenever we are considering runoff, infiltration will act like a loss, right? So it is the average rainfall above which the rainfall volume is equal to the runoff volume, right? So basically what is phi? What is phi? Phi is that particular line or particular point beyond which all the amount of rainfall will act like a runoff. Clear? No? Okay. So look at this relationship. What was the second relationship, or in that slide that was the first relationship actually? What was the relationship? Huh? F is equals to I. F is equals to I when I less than FC. This was the relationship, right? So look at this relationship and this one as well, right? So if intensity is lesser than infiltration capacity, then there will be no runoff, right? But if it is excess or if it is having a greater value than the FP, that is infiltration capacity, there will be a runoff. Obviously, all the volume of water will not be infiltrated. Some volume of water will act like a runoff, or will act like runoff, right? So suppose we are having this phi. What is phi basically? Phi is the average rainfall capacity, you can say, right? Average rainfall capacity, we are considering this as phi index. Though in phi index, rather than infiltration, the initial losses are also considered. So we will consider initial losses as the phi index as well. However, the losses obviously will not take part in the runoff. Yes or not? Losses will not take part in the runoff. Obviously, the other amount or beyond that losses, whatever the volume there is, that will act like a runoff. ठीक है ना? So if this is the losses and these are the intensities of rainfall, so if intensity is lesser than phi, all the volume of water will be infiltrated. Yes or not? Yes or not? Look at that equation, na? If intensity is lesser than the loss of phi, obviously all the rainfall will be infiltrated. So there will be no runoff. Only when the intensity I is greater than the FP, in this case phi, then excess amount of water will act like a runoff. So that this definition will go like this one, na? It is the average rainfall above which the rainfall volume will act like a runoff, will be equals to the runoff. So if you collect or add up those volume, this will provide you the volume of runoff. Yes or not? This is nothing but the volume of water which is actually acting like a runoff. Yes? No, this is in depth. So this is centimeter per hour. If you find out the area of this particular block, suppose if you are finding out the area, now tell me what you are getting actually. Centimeter per hour, that is depth per unit time, multiplied by the time, that means you are getting the total depth in that particular time, right? So that is the total depth which is being the runoff for that part, right? Now see, if you add up all the values, that is the total amount of runoff. Total amount of runoff. Clear na? এবার বোঝা গেছে? আচ্ছা. So it can be derived from the rainfall heatograph or hydrograph, whatever you say, knowing the resulting runoff volume. So if the runoff volume is known to you, and if the heatograph is with you, that means it is also known, then you can find out the phi value. How? Okay. The initial loss is also considered as infiltration. What I actually already said, that infiltration and the initial losses are also considered in phi index, right? So this is not about the infiltration only, all the initial losses are considered. So the amount of rainfall in excess of index is called the rainfall excess or effective rainfall. So that means the excess amount of water which is beyond this index, that is phi index, will be called the excess rainfall or effective rainfall. Excess rainfall Q, as because you can get it from the name itself, that excess means after losses, completion or satisfying the losses, this is the excess amount of water, right? Or effective rainfall, why? As because after satisfying the losses, this is the effective rainfall which we actually get in the runoff, as because we know that our main aim is to get the runoff or the amount of volume of water which is actually flowing through the river. That is what we actually consider available water with us. In water budget we have learned that is the amount of water we are actually having in India. মনে আছে নাকি আমার জানা নেই এখনো মনে আছে নাকি? So whenever we are discussing about the Indian budget, we have seen that this is the amount of water which is actually flowing through river that is available to us. So as because this is available to us, this is the effective rainfall. Losses को लेके हम लोगों का कोई काम नहीं है, right? ठीक है? So how we can find out? The steps will be like this. Those are the steps how we can find out. Consider rainfall heatograph of event duration of D. Duration is D, and suppose the number of pulses are N. So this is one heatograph. Suppose this is the heatograph with respect to time. We are having the intensity of water, right? Clear? So we are having total duration of rainfall, that is D. Total duration is D, and those pulses or segments are suppose delta T, and we are having 1, 2, 3 up to n number of pulses. So obviously n multiplied by delta T will be equals to D, right? N multiplied by delta T will be equals to D. Okay, let I be the intensity of rainfall in the ith pulse. Suppose this is the ith pulse. This is the ith pulse. Now this intensity is the II. Clear? Now if the runoff volume is known to you, how we can find out the runoff volume? By finding out the stream flow, right? And that is also one chapter in your syllabus, that is stream flow measurement, how we can measure the stream flow. So in river you can find out what is the volume of water going outside the catchment area. So that will be the runoff. So if that volume RD, that is equals to RD, that is the runoff volume, then we can say first of all, so total rainfall P will be equals to total rainfall P will be equals to the intensity multiplied by time. Intensity multiplied by time. So if you suppose this is I1, right? I that means this is pulse number 1. So this is I1. If you multiply this intensity with delta T, what you are getting actually? You are getting the amount of water or depth of rainfall in this particular time period. So if you add up all the values, you will get the total rainfall. Yes or not? So basically P will be equals to, total precipitation will be equals to I intensities multiplied by time, segmental time, that is delta T, and where I will vary from 1 to n, as because n number pulses are there. So if you add up all the volume, you will get the total rainfall. Yes or not? Yes, na? Okay. Secondly, we are having this is as well, that is if phi is the phi index. Now phi is not drawn over there. I can draw like in this way. Suppose this is our phi. Now if phi is the phi index, then the precipitation minus phi into TE will be equals to RD. Precipitation is the total volume of water which is actually coming. Phi multiplied by TE is what? Phi is what? Is the intensity of loss. If you multiply the time during which the losses are occurring. So this will be the total loss. Yes or not? Yes, sir. So what is TE then? TE is nothing but the duration of rainfall axis, where all the losses are satisfied, right? So TE is not D, TE is not delta T, TE is the total time period where there is some excess rainfall. That means obviously excess rainfall, when this excess rainfall will occur after satisfying or completion of all losses. So whenever this excess rainfall is occurring, we can say that is TE, and phi into T is the total loss what we are having. So precipitation minus total loss we are having, that can be considered as the runoff, as because that will be runoff, right? Here by this equation we can find out the phi value. How? T is known as, because here the graph is with you. RD value is known as because you have measured the stream flow, right? So you have measured what is the runoff volume, right? So precipitation is known, this is known, this is unknown, and even this is also unknown, that is called TE. Now as because two unknowns are there, what we can do, we can assume one of them and check other whether it is satisfying the equation or not. So this will be one sort of trial and error method, right? As because two unknowns are there, phi and T. So if the rainfall heatograph and total runoff of depth, that is RD, are given, then phi index of the storm can be determined by trial and error procedure as given below. What is the procedure? The procedure goes like this one. Suppose we are having n number of pulses, whatever we have already drawn, out of which m number of pulses are there which is actually having excess rainfall. So if this is true, if suppose this is true, what is the number of what will be m equals to in our case? N equals to 1, 2, 3, 4, 5, right? 1, 2, 3, 4 and 5. So n will be equals to 5 in our case. What will be the value of m in our case? What is m? M is the number of pulses which are having excess rainfall. Now tell me what will be the value of m in our case. What are the number of pulses which are having excess rainfall? 3, right? So 1, this is having excess rainfall, this is having excess rainfall, and this is having excess rainfall. This is beyond 5, this is below 5. So this will be, all will be losses there. So m will be equals to 3 in our case. So let us say that m is the number of pulses. Now obviously m cannot be greater than n. N will be lesser or maximum equal to n. ऐसा हो ही सकता है कि all the pulses are having an excess rainfall. That may happen. So m may be equals to 1 or lesser than 1. M may be equal to n or lesser than n. Select m as because this phi we have drawn here. Other than that, phi is unknown. We cannot say what are the number of pulses over there which is having excess rainfall. So we have to choose a number m, right? So we will consider m equals to some value, that is maybe 5, maybe 4. It cannot be 6 obviously, as because n is 5. So it cannot be 6. So it can be maximum 5. So we can consider first of all m equals to 5. Let us take from the largest one, right? So we have to assume one value of m, right? Then we have to check whether we have chosen a correct value of m or not, right? So select m number of pulses in decreasing order of the of rainfall intensities II. Find the value of phi that satisfied RD will be equals to summation of II minus phi multiplied by delta D. Now, is this equation clear to you? Is the equation clear to you? What the equation saying? Thus II, that is the intensity of rainfall in ith number of pulse, minus phi, that means this amount, this is phi, this is intensity, so this amount, right, multiplied by delta T, that means this volume, multiplied by delta T, that means this volume. Yes, this is what? This is the depth of runoff for this particular time period. ठीक? What will be this depth? Same, II minus phi multiplied by delta T. So how many consideration there will be? M number of consideration there will be, as because M is the number of pulses which are having excess rainfall. So suppose we have considered M equals to 3 first of all. So obviously 3 number of M are there. So we can say where I will vary from 1 to 3 in our case, or in generalized equation that will be varying up to M. ठीक है ना? Now this will be the what? This will be runoff. This all values are basically runoff. So this should be equals to RD. Why I am saying should be? As because our assumption can be wrong. M may be not 3, M may be 2, or M may be 4. Right? That is why we need to do this in decreasing order. Let us first of all try to consider the maximum one, that is M equals to N. Then do it in decreasing order. Reduce the value. If this is not satisfying, that means your assumption is wrong. ठीक है ना? If not, this is not satisfying, this RD value is not equal to that one, so your assumption is wrong. Using the value of phi of step 2, you will get a value of you will get a value of phi over there, right? You will get a value from RD. So RD volume is given to you. I, that is your assumption. What are the number of pulses? II you can find. F is unknown, delta T is known, you can find out phi over there. So finding out the phi value, let us now see what are the number of pulses are there which is having intensity greater than phi. Clear? So first of all, what we are doing? We are considering three number of pulses are there, considering 3 number of pulses are there. Okay, this should be the equation. Here RD is known, I is known, 3I known, right? Phi is known, delta D is known. Phi is not known, II is known, delta D is known. We can find out phi from this. Okay, find out the value of phi. Now phi will be equal to something. Now let us see whether the phi is having a value of this, where number of pulses which is having greater than phi value is equals to 3, or the phi is somewhere here. Suppose the phi value is coming here. That means number of pulses which is having greater than phi value is 1. What you have assumed? 3. You have assumed number of excess rainfall 3, but you are having number of excess rainfall pulses 1. That means your assumption is not correct. Clear? Assume a different value. Now assume M equals to 2. Find out the value of phi. See what are the number of pulses having intensities greater than phi, whether that number and your assumed number are equal or not. So do it until and unless M is equals to MC. MC is what? MC is nothing but finding out the number of pulses using the phi value. Let us take an example, then it will be clear to you Suppose we are having these intensities. The intensities are not directly given, but the cumulative values are given. Cumulative values are given with respect to time. That means intensities are given. So from 0 to this is 0.4 in 2 hours. So intensity will be 0.4 by 2. 0.4 to 1.3. Change in depth. Change in depth equals to 0.9 divided by 2. That is the intensity during this period. So you can find out the intensities in all the period. Find out all the intensities. Remember, the runoff is given. Runoff is given and the duration is given. Though duration you can get from this chart as well. So we can find out the intensities, incremental depth of rainfall, then intensities of rainfall in various pulses. Clear? Number of pulses are known, various intensities II are known, right? Okay, delta T is also known. First of all, what I have said, assume one value m which will be considered as the pulses, number of pulses which is having excess rainfall. Let us assume that m equals to 8. What are the number of pulses over there? Number of pulses, 8 number of pulses are there. First assumption is out of 8, 8 is having excess rainfall. All the pulses are having excess rainfall, right? Delta T is 2. So TE will be equals to m. TE and not m multiplied by delta T. TE equals to m minus m multiplied by delta T. Why? What is TE? TE is the duration where the excess rainfall is occurring. So we have assumed all the pulses are having excess rainfall. That means in total duration it is having excess rainfall. So TE is equals to D basically. TE is nothing but D, that is 16 hours. Clear? Now our formula is this one, RD is equals to summation of II minus 5 multiplied by delta T, where I will vary from 1 to m. Here m is equals to 8. All the values are having excess rainfall. So RD value is known, it is given. RD, the depth of runoff is given. Now here that runoff is given in terms of depth. Remember, if the runoff is given in terms of volume and the catchment area is given, you have to find out the depth. Here depth is directly given. Clear? Depth is directly given here. But if the runoff volume is given and the catchment area is given, you have to divide the catchment area to find out what is the depth of runoff. So depth of runoff RD is equals to this. This will be equals to this. II are known, right? Only unknown is 5. By this equation you can find out, put all the values of II. Put all the values of II multiplied by 2, that is the delta T, minus 16 phi, that is TE multiplied by 5. Clear? Only unknown is phi, you can find out the value of phi. Now phi is coming 0.263 centimeter per hour. That is our losses, phi. Now obviously with respect to your assumption, all the intensities of rainfall should be greater than your phi value, as because you have assumed all the intensities are having excess rainfall. So all the intensity should be equals to greater than or equals to whatever it is, 0.263. What are the intensities we are having? Intensities 0.2. This is lesser than phi value. So here excess rainfall will not occur. Here will occur, it will occur here, it will occur here, 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 not here. কত ছিল 2.60. So obviously this will not having excess rainfall as well. So we can see two number of pulses are there which are having not. So here MC is equals to how much? 6. MC is equals to 6, but MC is not equals to M. Your assumption was not correct. So then trial 2, assume M equals to 7, reduce your value. Similarly, you have to put all the II value. So 7 number of II value will be there. Which will be omitted? Which will be omitted? As because your value will vary now 1 to 7. So one pulse we will not consider. Which pulse we will not consider? The last one, the least value of intensity. That is the first, that is 0.2. Right? This 0.2 is having the lesser intensity among them. So you have to eliminate this one. We will consider other intensities. We will consider other intensities multiplied by delta T. Now here it will be 14 as because TE will be 14. 7 number of pulses are there. So 7 number of pulses multiplied by delta T, that is 2. So this will be 14, 5. You will get a 5 value from this as well. Now again, let us see whether all the intensities, all the 7 intensities you have considered, you have avoided the last one. So all the other intensities is greater than this or not. Let us see. 0.271, right? 0.271. It will not be considered. This is greater than 0.271. This is greater. This is not greater. Now again, MC is equals to 6, but your assumption was equals to 7. M equals to 7, so MC is not equals to M. Reduce the value again. Now M is equals to 6. What are the two pulses we will not consider? The least two one. Least, which are having least intensities. The last one and the first one. Clear? So those two will be omitted. Other intensities will be here multiplied by the delta T multiply or minus 12. Why 12? Again, M equals to 6, delta T equals to 2. So 12, that is the TE multiplied by 5. From this equation you will get a value of 5. Now here the 5 value is 0.275. Now let us see whether 6 number of pulses we have considered are having greater intensities rather than 5. This is greater. Yes. MC is equals to 6. Now MC is equals to M. Then you can say your assumption is correct and 5 value is this. Here, this is one example. This is the graph ultimately, that those are the heatograph, those are the intensities, and your phi value is now this one. This is another example there. You can take picture of it, try to solve it as because the solution is not here. Try to solve it. সেটা আমিও জানি তোমরাও জানো যে করবে না হয়তো, but still I will say try it. I should say that water resource engineering, that is particularly hydrology, is not so hard, but it is lengthy. In all the examples you can say lengthy, but not so hard. There are no sort of equations are there. You have to remember something other than those empirical formulas. That should be remembered. But you don't have to, derivation and all and other things are not there, right? Simple arithmetics are there till now at least. Okay, thank you. Another thing is there, that is called the W index. And what is W index? Likewise the phi index. In phi index we have said that initial losses will be considered in phi index, but in W index initial losses are not considered. So ultimately eventually your equation is W index will be precipitation minus runoff minus the initial losses divided by the excess rainfall time period, the duration of excess rainfall. TE is the duration of excess rainfall. So W index basically is equals to this one, where the initial losses are not considered. You are subtracting the initial losses. This is the, okay. Okay, now thank you.